Hi team, thanks for showing up for your learning one last time today. One last lesson for today. We have looked at how to solve trigonometric functions using Desmos, using a graph, which is great because we're all working on Chromebooks or working on our family computers or personal computers, and we all have access to Desmos, so practice Desmos makes you a better mathematician. But also, you might have times where you want to solve these functions. You don't have access to Desmos, a test, or you want to have two methods to do the same type of problem. And that's where doing these algebraically can be very useful. So let's take a look at how you do those. You definitely need to know how to use BEDMAS to solve trigonometric functions. So if you haven't, watch that video. And now let's go ahead and we'll do that. And we're going to solve trigonometric functions as arithmetic series algebraically. So let's take a look. So if we go back to this example, for what values of f of x, for what values of x does f of x equal 1/2? Okay, so first thing is write it out. We would say 1/2 is equal to cosine of 18x. All right, and we know that cosine can hit 1/2. All right, we don't have an a or a c here that's going to change the amplitude or things, but we know that it hits 1/2 and it hits 1/2 twice. Okay, where does it hit 1/2? Well, you want to think of your unit circle, and you can also use your cast rule. Okay, so I know cosine is positive down here. All of them are positive up there, so that's where I'm going to find my two solutions. The s and the t from the cast rule are not going to give me solutions because cosine is not positive over here. It's only positive over there. And I want to create a situation where this is 1 long and this is 1/2 long. Okay, and I remember that there's a special triangle that does that, 60 degrees, and then I can reflect that down here, negative 60 degrees. And those would be my two solutions. Well, my two starting solutions. They're each going to generate an arithmetic series, and I can then list all the possible solutions to this equation. Okay, so at this point, algebraically, you take the inverse cosine of both sides, which is, this is what we're doing. We're saying what angle gives us a cosine of 1/2. And if you take a look at your unit circle, here it is down here, 1/2, 300 degrees, that's negative 60, or up there 60 degrees and 1/2. Both are cosine. So we're here. All right, so let's write those in. Cosine inverse of 1/2 is equal to 18x. Basically taking the cosine inverse of both sides, like cancels that cosine, moves it over there. It's like, yeah, when this comes over, it becomes cosine inverse. Okay, so I don't like that type of thinking. All right, so now we solve this. Okay, so we say this gives us two equations. We're not going to use a chunky blue pen. This blue pen is fine. One solution is going to be negative 60 is equal to 18x. But we could also have this solution over here. Positive 60 is equal to 18x. And you might be saying, Mr. Jennings, we never write positive. It was just 60, and you would be right. Okay, so let's solve this one first. Divide both sides by 18. And I see that's going to create thirds. All right, so let's see. This gives us x. Okay, negative 60 over 18. Well, let's reduce that fraction. Okay, I see they're both divisible by 6. So let's take the factor 6 out, and I have negative 10 over 3. There's one solution. Or this one. Divide both sides by 18, and you get positive 10 over 3 equals x. Right, it's just positive one of that. All right, so there we go. Let's check what we got graphically. Oh, and then how do I turn this into an arithmetic series? Well, I can make this one here. I'm going to make one or the other. This one here, we'll call that t1 of n is equal to, this is our starting term, 10 over 3, plus the period What's the period here? 18x. So the period, he's pretending he doesn't know the answer. Okay, so I remember that period is equal to 360 divided by k. Well, that's equal to 20. Okay, so I could say t of n is equal to the first term, which we found there, plus the period multiplied by n. I could use n minus 1 too, it's fine. It would be the same. And then the other arithmetic series can be given by this number. T2 of n is equal to negative 10 over 3 plus also the period over n. Okay, so those are two different series, and they should generate the infinite list of solutions. Let's see what we had over here by graphing. We had 3 1/3 plus 20n. Oh, that's different, Mr. Jennings. No, it is not. 10 over 3 is 3 1/3. It's the same thing. Okay, why? Because there's 9 over 3 is 3, and then the remainder 1 over 3. Okay, all right, so that is the same, if you're wondering. And then T2, negative 3 1/3 plus 20n. There it is. Boop, right there. Great. So that's how you solve those by algebra. And I hope you've had a profitable day of distance learning today. I'm actually thinking I'm going to go add some questions to you about how to build the upcoming days together so that we have the most fun. And I look forward to your questions in the chat or by email. Bye for now, everybody.